Welcome back to another explainer. Today, we're taking a pretty fascinating journey straight into the microscopic engine of your body. We're going to explore the fleeting but absolutely vital role of a nutrient I know you've heard of, but maybe don't fully understand. I'm talking about vitamin B1. Honestly, you can think of it like the invisible spark plug that keeps your whole biological machinery running.
Here's our roadmap for today's explainer. We'll start with the water-soluble reality of B1, then look at how it unlocks energy from carbs, how it protects the nervous system, check out daily requirements and sources, and finally look at the very real dangers of deficiency. Let's get right into it.
Section 1, the water-soluble reality. Have you ever wondered why lacking certain vitamins can cause health issues like almost immediately, while others might take months or even years to actually show up? Well, it all comes down to a fundamental difference in how human biology manages its resources. You see, there's a clear divide between two categories of vitamins. On one side, we've got fat-soluble vitamins. That's your A, D, E, and K. Your body's actually really great at hoarding these. They're absorbed with food fats and basically accumulate in your liver and fat tissues over time. But B vitamins, including vitamin B1, well, they're hydrophilic. That means they're water-soluble. And because of this, they simply cannot be stored in the body to any significant extent. And that brings us to the chemical structure of our hero nutrient today, thiamine, or as we usually call it, vitamin B1. Because of its water-soluble nature, thiamine operates on a really strict use-it-or-lose-it basis. It's literally a ticking clock for your daily health. If your dietary intake is lacking, or say your metabolic demand suddenly spikes, a deficiency can creep up on you incredibly quickly. Moving on to Section 2, unlocking energy from carbs. Okay, so the absolute most crucial point is this. Vitamin B1 is strictly required for the metabolism of carbohydrates. Think about when you eat a huge bowl of pasta or a slice of toast. Your body needs to turn that food into usable fuel, right? Well, without vitamin B1, that critical metabolic pathway just completely hits a roadblock. No B1, no fuel. But here's the thing. Vitamin B1 doesn't do all this heavy lifting alone. It actually acts as a precursor to something called thiamine pyrophosphate, or just TPP for short. You can think of TPP as the active, literal molecular key. Without this specific key, several absolutely critical enzymatic reactions inside your cells remain permanently locked tight. Let's look at how this builds on our understanding of energy. TPP basically has two main metabolic roles. First, in the Krebs cycle, it acts as a necessary coenzyme for the oxidative decarboxylation of pyruvate and alpha-ketoglutarate. Now, I know that sounds incredibly dense, but simply put, it's the specific chemical reaction that generates ATP, which is the ultimate energy currency of your cells. Second, in the pentose phosphate cycle, TPP is required for trans-ketolase reactions to synthesize pentose sugars, and those sugars are vital for forming nucleic acids. It's serious cellular machinery at work here. Section 3. Protecting the nervous system. Now, your nervous system is incredibly demanding. Nervous tissue is highly dependent on a continuous, totally uninterrupted supply of energy derived directly from glucose. So, because we've already established that vitamin B1 is the key to carbohydrate and glucose metabolism, its role is intrinsically linked to your neurological health. It's a simple equation, really. No B1 means no glucose fuel, and no glucose fuel means a starving nervous system.
Thiamine is working incredibly hard behind the scenes here. Beyond just keeping the lights on with energy, it actively maintains the overall healthy status of your nervous tissues. Plus, along with other B vitamins, it's involved in synthesizing the very neurotransmitters that allow your brain cells to communicate, so it directly supports cognitive function. Oh, and like other hydrophilic vitamins, it actually functions as an antioxidant, actively protecting your cells from oxidative stress. It's a real multitasker.
Section 4, daily requirements and sources. So, how much do we actually need? Well, it all comes down to a surprisingly tiny number, 0.4 milligrams. Your body needs just about 0.4 milligrams of vitamin B1 for every 1,000 kilocalories you consume. It's an incredibly small amount, right? And the good news is that for most people, this requirement is easily satisfied just by eating a normal, balanced diet. So, where exactly can you find it? You can easily get rich sources of thiamine from everyday foods like cereals, legumes, pork, and brewer's yeast. But here's something truly fascinating from our source material. Vitamin B1 is also partly produced right inside you by your very own gut microbiota. Yeah, your digestive bacteria are actually in there helping to supply this essential nutrient. Pretty cool, right? Which brings us to Section 5, the dangers of deficiency. Because B1 cannot be stored, a severe chronic deficiency is a very real possibility. And when it happens, it leads to a devastating clinical condition known as beriberi.
Remember how we said TPP was the molecular key to unlocking your energy? Well, without that key, your body literally suffers widespread systemic failure. The symptoms of this chronic deficiency are incredibly severe. We're talking about nervous system damage, leading to general deterioration and cognitive dysfunction. It causes serious gastrointestinal disorders related to beriberi. You'll even see cardiovascular problems because the heart muscle itself suffers from impaired energy metabolism. And overall, the patient just experiences profound fatigue and weakness as all those basic metabolic processes grind to a halt.
The source text explicitly highlights a critical real-world example of this, noting that chronic deficiency is actually particularly common among alcoholics. This perfectly illustrates the danger of a water-soluble vitamin. You see, if a person relies heavily on alcohol rather than a balanced diet, their daily intake of thiamine just drops, while the metabolic stress on their body skyrockets. And because there are simply no reserves to draw from, that physical and cognitive decline can be shockingly rapid and severe.
So we're left with a pretty powerful realization about our daily health. Considering you literally cannot store vitamin B1 for tomorrow, we all kind of have to ask ourselves, is your daily diet and the health of your own gut microbiota actually providing the consistent thiamine that your nervous system demands today? It's a delicate daily balance, and honestly, unlocking your body's true energy potential depends entirely on it. Thanks for joining me for this explainer, and hey, keep feeding that biological engine.